The USS Gerald R. Ford, designated CVN-78, represents a turning point in the history of aircraft carriers and modern naval warfare. As the lead ship of the Ford-class carriers, it was designed not simply as a replacement for older vessels, but as a leap forward in technology, efficiency, and combat capability. Named after the 38th President of the United States, the ship embodies decades of naval experience combined with next-generation innovation. Every aspect of the carrier, from its power generation to its flight deck operations, was engineered to meet the demands of 21st-century maritime dominance. At its core, the USS Gerald R. Ford is a symbol of scale and power. Stretching over 1,100 feet in length and displacing more than 100,000 tons, it ranks among the largest warships ever built. Yet its true strength lies not just in size, but in what it can sustain and project across the globe. Designed to operate with a crew of roughly 4,500 sailors, including the air wing, the carrier functions as a floating airbase capable of launching continuous combat, surveillance, and humanitarian missions without reliance on foreign land bases. One of the most revolutionary features of the USS Gerald R. Ford is its nuclear propulsion system. Powered by two advanced nuclear reactors, the ship can operate for decades without refueling. These reactors generate significantly more electrical power than previous carrier classes, a crucial advantage in an era where weapons, sensors, and support systems increasingly depend on high energy output. This surplus power enables the integration of future technologies, ensuring the ship remains relevant as warfare evolves. Flight deck operations define the identity of an aircraft carrier, and here the USS Gerald R. Ford truly stands apart. The introduction of the electromagnetic aircraft launch system, known as EMALS, replaces traditional steam catapults. This system uses electromagnetic force to launch aircraft more smoothly and efficiently, reducing stress on airframes and allowing a wider range of aircraft, including lighter unmanned systems, to be launched. EMALS improves sortie rates, meaning more aircraft can be launched in less time, directly increasing the carrier's combat effectiveness. Equally transformative is the advanced arresting gear system, which replaces older hydraulic arresting gear. This technology provides more precise control when recovering aircraft, improving safety and reducing maintenance demands. Together, EMALS and advanced arresting gear significantly enhance the tempo of flight operations, allowing the USS Gerald R. Ford to generate more sorties per day than its predecessors. In real-world terms, this means sustained air power during high-intensity conflict and faster response during crisis situations. The ship's flight deck layout itself was redesigned to improve efficiency. By relocating the island structure further aft and optimizing aircraft movement paths, deck crews can handle aircraft more safely and quickly. These changes may appear subtle, but on a carrier where seconds matter and hundreds of operations occur daily, such refinements can determine mission success. Beyond aviation, the USS Gerald R. Ford incorporates advanced defensive systems to protect itself and the fleet it supports. Equipped with radar and sensor suites designed to detect threats across air, surface, and subsurface domains, the carrier serves as a command and control hub. Integrated defense systems allow it to coordinate with escort ships, aircraft, and submarines, forming a layered shield against missiles, aircraft, and other hostile forces. This networked approach reflects modern naval doctrine, where information dominance is as critical as firepower. Life aboard the USS Gerald R. Ford reflects a balance between operational intensity and improved habitability. Designers focused on reducing crew size compared to older carriers, relying on automation and smarter systems to handle tasks previously requiring large manpower. This reduction lowers long-term operating costs and improves efficiency. At the same time, living spaces, work areas, and medical facilities were upgraded to support crew well-being during extended deployments. A carrier deployment can last months, and maintaining morale and readiness is essential. The air wing aboard the USS Gerald R. Ford is another defining element of its power. Typically consisting of around 75 aircraft, the air wing includes fighter jets, electronic warfare aircraft, early warning platforms, helicopters, and support planes. These aircraft allow the carrier to conduct a wide range of missions, from air superiority and strike operations to reconnaissance, anti-submarine warfare, and disaster relief. The flexibility of the air wing ensures that the carrier can adapt to changing mission requirements anywhere in the world. Strategically, the USS Gerald R. Ford plays a central role in power projection and deterrence. Aircraft carriers are often among the first assets deployed during international crises. Their presence alone sends a powerful signal, demonstrating the ability to deliver sustained military force without escalation to ground invasion. The Ford class, with its enhanced sortie rates and advanced systems, amplifies this deterrent effect. Potential adversaries must consider not only the carrier itself, but the coordinated power of the entire carrier strike group. The construction of the USS Gerald R. Ford was itself a landmark achievement. Built at Newport News Shipbuilding, the only shipyard in the United States capable of constructing nuclear-powered aircraft carriers, the project involved thousands of engineers, technicians, and skilled workers. The ship served as a testbed for new technologies, and while this led to challenges and delays, it also laid the groundwork for improvements in future Ford-class carriers. Lessons learned from CVN-78 are already shaping the development of its sister ships. Operational testing and early deployments have demonstrated both the promise and complexity of such an advanced vessel. Introducing new systems on this scale requires extensive training, refinement, and adaptation. Over time, these technologies are expected to mature, delivering the full operational advantages envisioned by designers. The USS Gerald R. Ford is not just a ship, but a platform for continuous improvement in naval warfare. In humanitarian and peacetime roles, the carrier's capabilities are equally significant. With vast medical facilities, aviation assets, and logistical support, it can respond rapidly to natural disasters, providing aid, evacuation, and medical assistance. History has shown that aircraft carriers often become lifelines during crises, and the USS Gerald R. Ford continues this tradition with enhanced capacity and efficiency. As the flagship of a new generation, the USS Gerald R. Ford represents the future of carrier operations. It reflects a shift toward smarter systems, higher efficiency, and adaptability in an unpredictable global environment. While debates about cost and complexity continue, there is no denying the strategic value of a platform that combines mobility, endurance, and overwhelming air power. Ultimately, the USS Gerald R. Ford is more than steel, reactors, and aircraft. It is a statement of intent, showcasing how technology and experience converge to shape naval power. As it sails the world's oceans, it carries not only aircraft and sailors, but the evolving doctrine of modern maritime dominance. In an era defined by rapid change and emerging threats, the USS Gerald R. Ford stands as a testament to innovation, readiness, and the enduring relevance of the aircraft carrier in global security.